Hello everyone, I am Parinder Kaur. I am here to present on my thesis topic, which is effect of atmospheric cold plasma on the properties of millet starches. So as we know, starch is the insoluble component of the food, which when subjected to heat and water forms a thick paste like this, because of which it finds use as a water retention, thickening, bulking and gelling agent in various industries such as textile, pharmaceutical, paper and food industry. However, sometimes poor properties such as low water solubility can limit its use. Therefore, there is a need to produce modified starches from native starches with tailored and specific end use. If we look at the current sources of starch, potato, cassava and wheat are being majorly used for starch extraction. However, there is an endless increasing demand of starch owing to different uses. Therefore, there is a need to explore alternative uses of starches, and one such source can be millets, because they contain 70 to 80% starch. Moreover, they are underutilized and their per capita consumption is continuously decreasing because of increasing urbanization and changing taste preferences. Also, India is the largest producer of millet in the world with 38% of the entire world's production, which motivates us to explore millet as a source of starch. Now, millet was subjected to cold plasma, which is basically the fourth state of matter, which contains positive ions, negative ions, electrons, metastables, atoms, free radicals and photons, a mixture of which is capable of causing certain changes in the starch. So, pearl millet and finger millet starch was isolated and it was subjected to increasing voltages, which is 170, 200 and 230 volt, and 3 different time interval 10, 20 and 30 minutes by a pin to plate plasma system, and different changes were studied. So with the help of the changes studied, it was noted that the starch underwent oxidation and functional group incorporation, as noted that the CH2OH group of the starch was oxidized to carboxyl group, which was further oxidized to carbonyl group. So there was incorporation of functional group as well as the oxidation of the starch. Cross-linking was also noted, that there was basically the two amylose chains tend to come together owing to dehydroxylation and form a cross-link network, and depolymerization also occurred, wherein the amylose chains, mainly at the higher voltages, were broken down by the plasma reactive species to smaller chains of amylose, and there was also another change observed, which was the formation of fissures or pores on the surface of the starch because of the cold plasma treatment. However, if we look at the findings and the conclusion, there was a difference noted in the pearl millet and finger millet behavior, as we see that pearl millet observed a combination of cross-linking as well as depolymerization at 170 and 200 volt. However, finger millet noted mainly depolymerization with only some cross-linking at intermediate volt, that is 200 volt, whereas both the sample noted severe depolymerization at 230 volt, which is owing to severe plasma treatment, because more reactive species were able to cause more damage to the starch structure. However, if you look at the differences in the lower voltages, it can be attributed to the difference in their chain length and molecular weight. As we see, pearl millet has smaller chain length and molecular weight, so it was susceptible to mainly cross-linking, whereas finger millet, owing to its larger chain length and molecular weight, was more susceptible to depolymerization by the plasma species. Therefore, the study was able to conclude that the plasma changes depends not only on the time voltage but also on molecular weight, starch type and chain length. Thank you.